Good morning, students. Welcome to the lecture series of parallel computing. In today's lecture, I am going to discuss about the sieve of Eratosthenes using a data parallel approach and Amadel's law. In the previous lecture, I have discussed about the prime finding algorithm sieve of Eratosthenes using control parallel approach, how this algorithm works in control parallel approach and the disadvantages associated with the control parallel approach if the processor works in asynchronous fashion. So now in today's lecture we will see what is data parallel approach and how the sieve of Eratosthenes can be computed using a data parallel approach. So first, let's see what is a data parallel approach. Data parallel approach means when the same set of instructions are executed on different data set, then it is known as data parallel approach. And we will see if how this data parallel approach can be used to compute this prime finding algorithm. Data parallel approach means we are working in an environment where we are having more than one processor. So here we have n number of processors starting from P1 to Pn, and each processor having a three variable, like one variable will store the current prime, there is a variable which store the natural number, and the third variable store the index of the loop. So these three variables are used by each processor. Now how this data parallel approach works. Here every processor will be responsible for striking a segment of the array representing the natural number. In the control parallel approach, what we have observed that we take n natural numbers, and different processors are engaged in performing or engaged in striking out the multiples of the current prime. For example, if the first processor is engaged in striking out the multiples of true, the second processor will be engaged in striking out the multiples of 3. The next processor will be engaged in striking out the multiple of 5s. In this way, all the processors are executing the different tasks on the different data elements. But in data parallel approach, we give a segment of natural number to each processor, and then processor will strike out the multiples in its own segment, and it will inform to the other processor. Now let's see. Here this algorithm is data parallel because each processor applies the same operation. It means striking the multiples of a particular prime to its own portion of the data set. Here we will assume that there are P processor and n natural number. Now the question arises, if we have number of processors, then how they communicate to each other? There are two ways through which they communicate to each other, either through a shared memory or message passing. We will assume that in data parallel approach, the processors are communicating using a message passing. Here we have P number of processor and n natural number. Every processor is assigned no more than n by P natural number. Now if we will say that we have to assign a portion of the natural number to each processor, then what will be the amount of that portion? It will be not more than n by p, where n is your natural number and p is the number of processor. All prime which are less than root n as well as the first prime greater than root n are in the list of natural numbers controlled by the first processor. Now, which segment will be given to the first processor? The first processor will contain first prime number as well as first prime number, all prime, sorry, the first processor will contain all the primes which are less than root n and also the prime which is greater than, also the first prime which is greater than root n. This portion will be assigned to the first processor, and then processor 1 will find out the next prime and broadcasts or communicate its value to the other processor so that the processor can strike out the multiples of that particular prime. In this fashion, this data parallel approach works. Thus, the process of finding prime and striking of composite number continues until the first processor reaches a prime greater than root n. So what we have observed that in data parallel approach, each processor is assigned a segment of natural number. The first processor will contain all the primes which are less than root n and a first prime which is greater than root n. This value will be assigned to the first processor. In this way, in this fashion only, we will assign the portion to the other processor also. The first processor will take the next prime number and it will broadcast this value to the other processor so that they will get to know that currently this value is taken, and they all will strike out the multiples which are present in its data segment, So this is how a data parallel approach works. Now we will learn about what is a speed up. Now, speed up is a ratio and it is denoted by S of P. The ratio between the execution time using one processor, or you can say that the time needed by the algorithm, best algorithm of the sequential process, and the time needed when the same problem is executed with a P processor. Then this is known as the speed up factor. How we will define a speed up factor? It is the ratio of the time needed by the best sequential algorithm divided by the time needed by the same problem using the P processor, or the time needed by the same algorithm when executed in the parallel environment. So here Ts by Tp, where Ts is the execution time on single processor and Tp is the execution time on multi-processor. Speed up always gives the increase in speed by using a multiprocessor. And there is always a difference in time required to execute a best sequential algorithm on a sequential processor and the time required by the same problem when executed in the parallel environment. So maximum speed up is usually P with P processor, that is a linear speed up,